Hello everybody, today we'll be doing trapping rainwater. Given an n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So here we have this input and it's called height, and we have an output of 6. The reason being we could trap water of 1 here at this location of 0, 1, 2, 3. Let's get the index out. I think that's particularly important here for us to see where we are. Okay, so what we see here is that we can store 1 water here. The reason why we can store 1 water here is because between 1 and 2, the minimum of 1 and the maximum of 2, we can store 1 water. Now, let's take a look at this other spot, 1. The reason why this 1 spot can retain 1 box of water is because it is between 2 and 3, a minimum of 2 and a maximum of 3. Between those, we could get has a height of 1, and so it will be 2 minus 1. Between 2 and 3, with a height of 1, 2 minus 1. So that's why we have 1 here. This 0 is has a value of 2 because it is between 2 and 3, and it has a value of 2, has a height of 0, so 2 minus 0. Let's keep going. Let's see what the next spot is. Next spot is 1, between 2 and 3. We have a height of 1, and therefore we have 2 minus 1. Okay, because the height of 1 is between 2 and 3. Now, 3 is a very tippy top, so it gets 0. Oh, same for this one. It's a tippy top between these two. There are no values higher than 2 on the left side, and because there are no values on the left side higher than 2, it is 0. And of course, to the right side, there is a 3. For the 3, there's no higher level of elevation to the left. There's no higher elevation to the right. And so it is 0. Now, let's check out this item here, 2. So 2, we have higher elevation on the left, 3, but we have no higher elevation on the right, so 0. Take a look at this one. This has an elevation of 2 on the left and 2 on the right, because of 2 higher elevation. So 2 minus 1, we have an item of 1 here, 1 block. Now 2, take a look at the left, we have a height of 3, that's the highest point, but to the right there's nothing, so 0. And 1, it's always going to be 0 no matter what we do, because there is no item to the right of it. So there's no item, because there's no item to the right of it, it's like -1 essentially. And there's not going to be anything higher than that. Let's talk about these first two. The same thing with this one. So this one has no higher item on the left, so 0. And this item has no higher item on the left, so 0. Okay? Because the highest item on the left is 0 right now. The highest item is on the left, it's going to be 1. Okay, so looks like we identified the important points here. We got a total of 1, 2, 4, 5, and 6, a total of 6 here for our output. And I think we just basically ran over how to do this problem by just going over it one time. Give me a moment. I need to open the door. Okay. Let's take a look at some edge cases. So here's another example case where the sides are higher than the So as we said earlier, this is going to be 0 because left it has no higher elements. This is going to have the highest element of 4 on the left and 5 on the right, so it will be a total of 3. This has a highest element of 4 in between. This has a highest element of 4 in between, so it's going to be 1. This has highest element of 4 in between, so 4, 2, because 4 minus 2, and this has the highest element of nothing on the right, so -1. So we have a total of 3, 4, 1, and 2. It should give us a value of 9, it says. So why is it so low? Because, sorry, 2 minus 2 is 2, that makes sense. 4 minus 2 is 2. 4 minus 3 is 1. 4 minus 0 is 0. 4 minus 2 is 2. Sorry about that. Yeah, so now, yeah, that makes sense now. So we have a total of 9, which is great. I think, do we have any other edge cases? Maybe nothing. We have, oh, that's not possible. The minimum height is between 0 and 10 to the 5th. What if we had n? How many heights are there? And we have to have at least one height. So that's the minimum, and that's going to be our edge case. So let's take 1 here, and our output is going to be 0 because there's nothing on the left. I mean, the thing on the left is -1, the thing on the right is -1. So we're going to output 0. Okay. With that, we're done. Let's get started with we're done with understanding, and let's start with matching. The match is going to be pointers. If we use pointers on the left and right max, then we can we can find the height of the value in the middle. So how do we do that? The plan. So starts with a pointer on the left and right. Create a left max and right max of -1. Update the left max and right max until they cross. For each value seen, get the minimum of left max and right max, subtract the current value. Yeah, and that's it. And add to total, collected rainwater. Yeah, and that's it. Return total collected rainwater. Yep, I think that should do it. That was essentially, we ran over it twice already. I'm sure that this works. Essentially, we codified what we have spoke about earlier. So let's implement it. So left and right pointer, left, right equals 0, and let's set it to length of heights -1. Okay, we have our left and right. So let's get our left max and right max. Well, left max and right max is equal to -1. Oh, okay, that's good. So while left is less than right, let's continue less than or equal to right, because I think they would cross, and we would need to handle that case in between. Yes. So let's start on the left side, and let's talk about that on the right side. So currently on the left and the right, and we have our left max at -1 and right max at -1. So let's update our left max and right max. So how do we know which one to update? Well, let's move the one with the higher height. Okay, so right has the higher. So if left is greater than right, then we'll shift left. Left plus equals 1. Of course, we need to get the total collected rainwater equals 0 at this point. And total collected rainwater is equal to, like we said, the minimum between left max and right max. Oh, let's set the water at 0, my bad. I think 0 makes more sense. Because you can't collect the water on the left and right side. When you have negatives, it causes weird stuff to go on. So we have the minimum between left and right, and minus the current value. Yeah, so 0 minus 0. Yeah, we're not going to get anything lower than 0, so that's not going to affect our total collected rainwater. If it was going to be lower than -0, lower than 0, then we would have to like take a min between this item and 0, but that's not the case. Then we do a L plus equals 1. One thing to note is that we have to update our left max first. So left max equals the max of this current item, which is the height of L, and left max. So that's that. With that, else, basically, right max is equal to the max of height of R, this current R, and right max. And we take the total rainwater minus the minimum, equals minimum, sorry, between this maximum and the current value. What is the current value, right? Well, the current value is actually height. Current val equals height of R, and the current of R, current val, is equal to the height of L, because we're looking at the left side and right side. So this is going to give us the value at this particular point. So did we finish up our algorithm? Yes, that's it. That's all our algorithm. And it looks like we're doing this one pass, which is pretty cool. And we're returning the total collected rainwater. Let's see if it works according to our first line of code. So first of all, we have 0 and 0. So right is higher, so we update the right, and we check if the right side minus the left side, we take the minimum minus the current value. So the minimum is 1, right? Yes. And then we take a look at the left, and we take a look at the right. So this is going to give us a 0 minus 1, which is not what we want. We wanted a 1 minus 1. Looks like we have to do the max afterwards, because that's, yeah, that's going to be a problem. We update the max afterwards. Okay, so now that we don't update the max first, so we have the 0 and 0 minus the current value. That's still the same. That's still going to be -1. Okay. So exactly the same issue. What are we going to do, right? We're going to have a negative number, and total collected rainwater is going to dip below our desired value because, well, that's not what was intended. We would never intended to get a negative value. And it's not going to be equal to, it's plus equals to. So how are we going to deal with that? We can deal with it with a max between min and 0. That's the easy way to deal with it. We'll deal with it better next time, maybe, when we look back at the code and we see something else. But that's what we have to do now that we're running through the code. So we're going to get 0 for our total collected rainwater, because we don't want to add any negative values. So we're done with that. So we deduct the R. So now we see a 2. 2 is going to be higher, and we update the 2. Okay, interesting. Are we updating the wrong item? Are we sure we're supposed to update the higher item instead of the lesser item? I think we should iterate the lower item. I think that's what's supposed to happen. Because if we iterate the lower item, then we can get until we move the higher item, then we can learn something new. Because currently what we're doing is we're losing information. Here's what I mean, we're losing information. Because we're iterating the higher item, we don't know what's going to happen to the lower item in the future. We don't know if we're going to get something higher for that lower item. That's what I mean. What I mean is, suppose we're at 0, and we're iterating the higher item until we get past it. But then we don't get what is higher on the left side because nothing has been iterated. This has been 0 the whole time. So by the time we get to 0, we're going to miss all of this. So we're going to try and iterate the lower item first this time, okay? I don't know if we need this line of code yet, but we're going to iterate the lower items first. So if a height of L is lower than the right, then we're going to iterate the right. If basically else the height of the right is lower than the left, then that means that we're going to iterate the right. So the left is lower right at this point. So we have a 0. Left max is 0. The new left max is also 0. And we get the minimum. 0 minus 0 is 0. And we do a L plus equals 1. So with that, we take a look at the next item. It is 1, and a 1. It looks like right is higher. Right is not. It's not left is not lower than right. So right moves left 1. Because left max is 0, and right max is 1, minus the current value of 1. We're going to get a 0 because the minimum is 0. So therefore, we'll reduce the R, and the right max is now 1. And we still have 0 rainwater at this point. Okay, let's look at the 2 and 1. 1 is lower, so 1, left max becomes 1. And we have a right max of 1 minus 1, which is 0, and we move to the right. Because we take the max between the left and the right, that's going to be, yeah. So with that, we keep looking, and this is going to be, this L points is 0. So basically, we have a left and right. Perfect. And we found that the minimum is 1. 1 minus the current value of 0 is 1. So we take 1 and we add it to our rainwater. This is exactly as we planned. Now we move the left pointer forward and we see a 2. As we see a 2, we update the left max. 2 and 2. Well, left is not less than the right, so we move the right pointer. As you can see, when we move the right pointer, we have a 2 here, and this is a 1. And 2 minus, so then 2 and 1, well, 2 is higher, so we take the 2 and we move that forward. There's nothing here, there's nothing here. Now that we are at 1 and 1, well, we're going to take the right. So right is going to be 1, and the 2 minus 1 is 1, so we take a 1 here, 2. We move this, shift this forward. We have a 2, so we have to shift a 1 first. 1 is going to be 2 minus 1 again. So then we're going to have a 3. We move this forward, and we have a 0. Of course, we're going to deal with the 0 first. So like look at the left and the right, we're going to get a total of 2, so we're going to have a 5. And we move the left, and we have a 1 and a 1. 1 and 1, we have a total of 2 minus 1, because 1 is less than 2, so we shift that one, so we get a 6. Now, lastly, we go to a 3. 3 is higher, so then we shift the left, and we basically, when that happens, there is nothing to add or subtract. So now we're at 3. With 3, we have a item of 3 for left and right. Right's going to be the higher one, so we took a look at the right. 3. So left max is 3, and 3 minus 3 is 0. And so we move the decrement to right down, and now we're done. We have gone through everything, and we're good to go. Okay, cool. Let me give a pause. I need to open the door again. Hello there. So we have a wrong answer here, and they made a print statement to see what was going on wrong, and we were missing the 3 and the 9 at this point. The reason why we're missing the 3 and the 9 is because, well, this 2 was not recorded as our high point, and we still had net 1 as our high point, even when we have reached this high point here at 2. Therefore, because L was at 3 and R was at 9, we were not able to update this. So how can we take care of this is basically we will shift this logic for shifting the L and the R down, but we will consolidate this logic here at the top, and we will be able to get the right answer. I'm going to give it a shot right now. Right, so after consolidating the code, it looks like we were able to update the left and right max properly at the right timing, and also grab the current value and update that. So, perfect. Yeah, this is still a little bit more complicated, but this is probably what I would get during coding interview when doing this problem. And I think that's fine. Everything's very descriptive, and although it might not be the most spectacular code, it works, and I think that's great. So let's run the example test cases, and let's submit this problem. Submit this and see if we have any other remaining issues. And no, we don't. We just have solved this problem, and that's pretty cool. Give me a moment and let me check out some other solutions that I have done before, and I'll pull that out for you. So previously, I submitted this type of code where it's minimal information, and it looks like what happened here was I updated first, and then I manipulated the values afterwards. I think that worked out for me, interestingly enough, because I set the left height and right height and moved those previously. So it was a little different type of thinking, and that led me to a different answer. Now, so also, let's think about the evaluation of this code, the time and space complexity. So what is the time? It's O of n. And what is the space? O of 1. Because, as we predicted earlier, because we just used pointers, no additional space, and time is one loop. Perfect. With that, I hope you enjoyed this video. If you have some nicer code to recommend, please submit it below. Currently I have this one here, as it's very lackadaisical and very little context. And this one here with a lot of context, and exactly what's going on here with the left and right max. Of course, this could have been updated to be better if we have updated these and updated the left and right before we began to update the information. So with that, I hope you enjoyed this video and you learned something today. That would be great. I'll see you in the next one. Thank you. Bye.